It is almost certain that at some point one would have heard the terminology bits, bytes, megabytes and terabytes being used when referring to computer storage capacity. As engineers, we have to be clear on the difference between these values, since there is a large difference between 100 bytes and 1000 bits. By the end of this video lesson, you should have some idea which of these is the greater and why. To understand this, we must have the basic knowledge on how computers measure capacity. The brain inside the computer is more or less the central processing unit, or CPU. The CPU basically works on transistors, and at one time these were large cumbersome devices. These days it's difficult to actually see them without a microscope, since they are so tiny and buried inside the CPU. In fact, there are about 40 million in an AMD Semptron CPU. This is an electrical symbol for a transistor, which will connect a bulb to it, then connect it to a switch and battery. When the switch is thrown, current can flow through the transistor and the bulb will light. In computer terms, these transistors can only be on or off. The off state can represent a 0 and the on state a 1. If we add a second transistor and combine the two states, then we can have them both off. Then we could say this again represents 0. Or if the first one is off and the second one is on, then this would represent a 1. This time we can switch the first on and the other off. This could represent a 2. Now if we switch them both on, this could represent a 3. So in effect, with the first example, with the one transistor we had two states 0 and 1. In the second we had four states 0, 1, 2 and 3. Let's increase this to 8 transistors and switch the other two off. So with all the transistors off, we could say 0, 0, 0, 0, 0, 0, 0, 0. This is binary. Remember, we are working from right to left. The next state would be 0, 0, 0, 0, 0, 0, 0, 1. This would be decimal 1. Next, 0, 0, 0, 0, 0, 0, 1, 0, or decimal 2. Next is 0, 0, 0, 0, 0, 0, 1, 1, or decimal 3. As the transistors are switched on from right to left, the numbers will increase. If this is the first time you have seen binary, it can be a difficult concept to understand to begin with, since normally we would be using numbers from 0 to 9, but in binary the only numbers that can exist is 0 and 1. Since we've exhausted the combination of the last two transistors, we shall switch them off and turn on the next one to the left. So the next binary number is 0, 0, 0, 0, 0, 1, 0, 0 or decimal 4. If we look at this closer, we could be tempted to say 100 binary is equal to decimal 4, but that would be wrong. The correct way of saying binary is 0, 0, 0, 0, 0, 1, 0, 0. Let's move on. This is the binary for decimal 5, for decimal 6, and for decimal 7. Once again we have exhausted the combination of the lower transistors, so we shall switch them all off and turn on the next to the left of the last transistor. You may think this is complicated, but when you analyse it, we are only using two digits, 0 and 1. A computer processor has no idea what the number decimal 64 is, but if we said 0, 1, 0, 0, 0, 0, 0, 0, it would understand. To see if we can make this a little clearer, let's create a conversion table. Under the far right transistor we shall put a 1. So when this transistor is on, it will mean a decimal 1. Let's double this number, making it a 2, and put that under the next transistor to the left of the first. Double the 2 and make 4 and put that under the next transistor to the left of the last one. Now if we switch on the last 3 transistors, then add the decimal numbers under the ones that are on, so that's 4 plus 2 plus 1, which makes 7. So binary 0, 0, 0, 0, 0, 1, 1, 1 is equal to decimal 7. Let's continue to double the last number and place them under the next transistors. So it would read 8, 16, 32, 64 and 128. We can see here that the binary 10000000 is equal to decimal 128. But what does the binary 00110011 equal in decimal? Well, that would be 32, add 16, add 2, add 1, making 51. If all the transistors are on, what is the maximum number? If you add 120 and 64 and 32 etc. together, it would equal 255. Next question is, what if we want a number larger than 255? We would simply string together another 8 more transistors. We can do a reverse conversion. For example, what is the binary for decimal 103? This example, we have to work from left to right. So the first transistor is switched on and we try and subtract 128 from 103. Naturally this will not work as it is too large and would result in a negative number. So this is switched off and we try the next, 64. This time we can subtract 64, so this is left on. The remainder is 39. From this we subtract 32, which again we can do. So I've subtracted 64 and 32, giving us a total of 96, leaving a remainder of 7. Naturally we cannot subtract 16 or 8 without leaving us with a negative number, but we can subtract 4 leaving 3. So that means we can subtract 2 and 1. The result is that 0110011 binary is equal to decimal 103. Now let's break this down. We started with just one transistor and this was the smallest value, which we call a bit. We then added further transistors to give us 8 transistors or 8 bits. 8 bits is equal to 1 byte, and storage capacity is usually measured in bytes. The first storage device is the floppy disk drive. It stores information on a floppy disk. It can store 1.44 megabytes of data on each disk or 1.44 million bytes of data. Or if we wanted to check how many bits, we would multiply this by 8, we would normally 11.52 million bits of data. Because this is still a small number relative in computer terms, we normally use bytes instead of bits when describing the storage capacity. We shall learn later how floppy disks can store this information. Next is the hard drive, which has much greater capacity and are measured in gigabytes or 100 million bytes. Larger hard drives are measured in terabytes or 1 million bytes. Confusing piece of computer terminology is GB and GB, which are actually totally different. A lowercase b signifies bit, whilst an uppercase b signifies byte. For example, 1K lowercase b is 1 kilobit or 1000 bits. To convert this to bytes, we divide this by 8. So 1 kilobit is only 125 bytes. 1K uppercase b is 1 kilobyte or 1000 bytes. To see how many bits this is, we multiply it by 8, resulting in 8000 bits. Further examples are M lowercase b or megabits is 1 million bits. M uppercase b or megabytes is 1 million bytes. G lowercase b or gigabits is 1000 million bits. And finally, G uppercase b or 1 gigabyte is 1000 million bytes. Although this may seem trivial, it can be important as a single byte equals 8 bits. You should try and be as accurate where possible. The floppy disk drive allows data to be stored on removable floppy disks. The most common type of floppy disk is a 3.5-inch 1.44 megabytes. This offers a tiny amount of storage when compared to hard drives or optical solutions. Because of this, the floppy disk has now all but disappeared in modern PCs and so will not be included as part of our practical tasks. The hard drive is a device that provides permanent storage for the computer system. An average PC will have a single hard drive, but it is common for multiple drives to be used, adding to storage and improving security of the data. A solid-state drive SSD is very much like a hard drive in that it also provides permanent storage to the system. Unlike a traditional hard drive, the SSD has no internal moving parts and uses flash memory to store data. This makes the drive function almost silent and increases load speed dramatically. However, SSDs are much more expensive than a mechanical hard drive and because of this provide less storage space. Some modern PCs now use SSDs to load the operating system and frequently used application. A traditional hard drive is then installed along this for increased storage capacity. Most entry-level systems do not currently include solid-state drive. Later, the difference between the SSD and traditional hard drives are examined. Next is the CD or compact disc and the DVD, digital versatile disc technology. Most modern systems may include a Blu-ray device. The storage capacities offered by such media varies from 650 MB CD up to 50 GB dual-layer Blu-ray disc, all of which are far greater than the 1.44 MB offered by a floppy disk.